really like using real life experiences for my students, and so on Friday I allowed them each to have a lifesaver to dissolve in their mouths so that we could collect some data on how long it took for an individual lifesaver to dissolve in your mouth. I then gathered that evidence, that I collected that data and used it as evidence for today's cause and effect investigation, where we tested different variables to see their effect on the dissolving of the lifesaver. Are you ready for science today?
Yes.
Like always. Like always, I love that. We're always ready for science. Okay. Scientists, we've been investigating what happens when you mix different substances together. And what do we call that when we mix different things together? What do we call it?
A mixture.
We call it a mixture, good. And we discovered that when we added salt and water together, something happened. What happened when we put salt and water together, Claire?
It dissolves.
What dissolves?
The salt dissolves in the water.
The salt dissolves in the water. Does everyone agree?
Yes.
Okay, so last week, you all dissolved a lifesaver in your mouth, and you recorded the amount of time that it took for that lifesaver to dissolve. And I took all of the data that I gathered from that, and I put it into this chart right here. So I want everybody looking at the chart, and I want you to make some sense of this data. What are you noticing? Talk to a neighbor. Okay, let's take a look at this data. So who noticed the colors? Tucker, do you know what the colors would represent?
Each table.
Okay, so for example, this purple lifesaver here, what do you know about that purple lifesaver right there? Amor.
It was the color of one of the people's.
And how long do you think this lifesaver took to dissolve in this person's mouth?
Less than 5 minutes.
How do you know that?
Because in the dissolving time chart it says less than 5 minutes, and it's in that, right?
Okay, so if we look at the data, what could we say about our lifesavers?
We could say that each color had its own different time, and not all green stopped at 6, or not all purple stopped at 5.
Good, so we had a really big range of dissolving times. Amor.
For the dissolving time, 5 through 6 minutes was the most common.
Good, and I heard someone say the least common was this one down here. So more common, less common. What's more important that we understand about this data? What are you wondering, Caleb?
I'm wondering, like, why 3 of them got less than 5 minutes when most of them got 5.
Okay, so some of them. What do you think caused the difference in the amount of time it took? Tell a partner.
Maybe.
Okay, can I get your attention back again? You guys did a really nice job of talking with each other about what might be the cause of why we had so many different times with our lifesavers. So share out one thing about what the cause might be. Sanaya, what do you think the cause might be?
It might have taken longer for the lifesaver to break, and if it breaks, there'd be more sugar coming out.
William.
Like if the lifesaver attracted lots of saliva in your mouth.
Caleb.
Maybe if their lifesaver wasn't on their tongue, but somewhere else in their mouth.
Okay, so maybe position in mouth. Well, scientists, today we're going to test out these ideas. We're going to see which of these ideas might be the reason we got different results for our experiment that we did on Friday. So, today we are going to think about cause and effect, just like we do in language arts when we think about cause and effect. We want to develop and revise a model like we did on Friday. We did a model of it in our mouth Today we're going to do a model of our experiment of what happens to this lifesaver as it dissolves in water. And specifically, I want you to think about your variable, because I'm going to assign each group a variable, and what is the effect of that variable on those lifesavers. Alina, did you have a question?
Oh, no.
Okay. So very quickly, our procedural vocabulary up here, we have, what are we going to call this thing here? A cup. I like it. What are we going to call this? A lifesaver. Could we call it something else?
Experiment.
Okay. Our testing variables today, movement. So if you move it around in your mouth, if you have more force, what will the effect be? Okay. We talked about temperature. If we add more temperature, do you think it will dissolve more quickly, more slowly? Take a guess before you start. Amount of water. Will the amount of water change your results? And finally, the size of the pieces. So somebody said, what if I chewed mine and someone else didn't? Will the size of the piece affect how quickly or slowly that lifesaver dissolves? Are we ready? Okay. Before you go back to your seats, what are you doing today? Today, you are going to consider cause and effect. So make sure that's what you're thinking about as you create and revise your model of what's happening to that lifesaver, not in your mouth, but now in a cup. And you're going to have two to compare, so I want some comparing and contrasting also. Okay? Any questions about what you're doing at your seats? Okay. First thing, read your experiment. There's 2 copies you can read with a partner. As soon as you're ready, you may get started. Back to your seats. Experiment. So what variable are you testing? Go quickly.
Movement.
You're testing movement. So how are you going to test the variable of movement in this experiment?
What's the difference? With the differences of one stirring and one just sitting there inside the water dissolving.
How do you know how much water to put in each cup?
This measuring.
Okay.
And we can measure equal amounts for each cup, 9 or 10.
Okay, so if we measure equal amounts for both cups, is that going to control that variable?
Oh, this is what
That's not a secret. That's what scientists do. So scientists make sure all their variables are controlled except one. So which one are you going to change? Movement. So one of it is going to move and the other one is not. And everything else has to be the same. Okay, get started so you have time to model on your paper.
Oh shoot. Alright, so looks like there's bubbles at the bottom on both of oh no, actually that's just there's bubbles at the bottom.
So it kind of looks like it's defrosting.
I feel like the hot water is gonna dissolve first.
And you
Like
kind
it's
of get
gonna dissolve more.
like you can kind of get the aroma of candy, like and like
You can smell it.
Yeah, you can smell it.
So this looks like it's wait, be careful, we don't want it to wait, it looks about the same. So but look at that one. Wait, keep your eye on the watch. Oh god. Okay, so it seems like I know, but this one has like it looks like there's like
It
looks
smells
like
really.
frost,
It smells
but it's
really
not.
good. I'm just saying.
Yeah. Oh my god. You can see like little tiny down here. It looks like frost almost, but it's not. With the candy, it looks like little bubbles. I smell green now.
And I kind of see like I can kind of see like sugar.
Yeah, maybe that's the sugar dissolve. Like it's dissolving.
Oh,
and
wait,
as it
guys,
dissolves,
coming
the
down.
sugar-
Guys, check this out. Like,
Well, look, it's on the top.
whoa.
I think that might be okay, and then you can see it over here too. So it looks like just move it around. Like there's more water for it to touch when it's in the water.
And how are you going to convey that in your model? Have you thought about how you're going to show that in your model? Because I'm noticing a difference in the color as well.
Yeah,
I'm wondering if you could catch that difference in the color in your model.
Because
Could
of
you
the
do that?
because the lifesaver right here, it's moving around, so it's getting all over in the water while it's melting. So all the red and all that, because the color is red, it's turning red, the whole thing.
I like that idea. I'm wondering if it's melting.
And because this one, and because
So Liam said it was melting. Do you want to tell him
that
something?
I see bubbles coming out of that one. That one's slowly dissolving, and it's red down there. That's because it can only touch the bottom and not everywhere.
What do you guys think about that? So Kelly said this one's exposed to more water. Does that make sense? Okay, how are you going to show that in your model? That's your next step. Think about how you're going to show that in your model. Oh, I like the way this model is demonstrating cause and effect. So the more water you have, what's the effect? Smaller, rough, bumpy. What about the effect of less water? Larger, smooth. Are you going to convey that in this model? What I like about modeling is it allows student thinking to be visible, so that as I'm walking around and taking my notes, I'm able to highlight different levels of understanding in my students. And then as a group, when we come to debrief, I know who to choose and who approximates, as well as who has got it. Oh, I like that we did ready, set, go. Why do we do that?
Because we're trying to do the time.
So when they go equally in the same time.
Oh, you want them to make sure that they both hit the water at the same time. Yeah.
Yes.
And why are you stirring one and not the other?
Because we want to know movement makes it a difference on the dissolve.
We want to know if one that's just sitting there in the water goes faster than one that's mixed in, or the opposite.
I like how you revoiced Kenya's idea. So she had a really good idea, but just kind of got stuck at the end, and then you kind of jumped in and helped her revoice that. That's what scientists do. They help each other.
Oh look, the color's barely coming out here. It's like a bubble in the water.
It smells like some bubbles. I can smell it from here.
I wonder if we were allowed to taste the water, if it would taste sugary.
One, they both smell like Pepto-Bismol. I think the flavor has an effect on the smell.
I think that because the sugar's red, I think that might be why it's turning.
No, I think it's because the food dye, because sugar's not red. It's just the dye.
Yeah, Kayla's right, the dye.
Isn't that why?
Okay, can I get your attention for just one moment?
Oh, Jesus, it's stuck.
Oh, thank you. Excellent. You have been investigating a certain variable. So one group tested movement to see the cause that movement had on the dissolving of the lifesaver. One group tested temperature to see the cause that that had on the experiment. So as you do your group model, I want you to think about what variable did you test and what caused that lifesaver to dissolve at a different rate. So try to show us that in your model. Work together. I want to see everyone's ideas in that one collaborative model. Thank you for your hard work.
Our causes, since there's more water in this, for this one, it dissolved more rapidly than the one over here, because it was the one with less water was more exposed to the air than this one.
So maybe the water level depends it.
Yeah, I think so.
And then here.
So we're mixing it.
And then
Let's see.
Yeah, then guys, if you did it before and after, it's just gonna end up the same. So we don't need to do the before and after because, you know.
Shouldn't we like draw the models and then like draw the little lifesaver and then put a little arrow to what it looks like at the end inside the cup?
Oh yeah, sure.
Yeah, that would be good.
Okay, Jasmine, will you start for us?
What we did is that we let one sit and the other we stirred it around.
And what results did you get when you stirred one and let the other one sit, Holden?
The one that we stirred, like it got more bright until it kind of just dissolved. But the other one, it got like small little parts, kind of like chippy parts, became white. But like little small parts just became white. But the other one, the whole thing kind of slowly became white.
Okay, Carter, can you add on to that?
One model that we mixed was dissolved faster than the other because I think what the movement changed, it made one lifesaver dissolve faster than the other, and with one, like how Holden said, the water was brighter, like kind of like a limeish green, and I think when the other one was completely dissolved, I think it made it like everything, all the color or whatever was added into it to make the color, it made the watercolor.
Okay, I really like how you showed before and after. I think that did a nice job of showing your cause and effect. Very nice. Today we examined these 4 causes as to why a lifesaver will dissolve in water. So we looked at movement, we looked at temperature, we looked at the amount of water and the size of the pieces. Now at your seats, I want you to think back to your Friday experiment, and I want you to develop your own idea about what caused your lifesaver to dissolve at the rate that it did. After looking over my student notebooks, I noticed that 4 of my students had really strong models that showed cause and effect well. I had 16 students that touched on cause and effect, but their models weren't as strong. And then I had 6 students who could make a model, but there was no cause and effect relationship shown there. So my plan is to have these 4 students come up in front of the class one at a time and share their models and how they showed cause and effect, while the other students have their models in front of them and can be revising on their own and figuring out what they can do to make their models stronger. I also plan to revisit cause and effect in the literacy block to see if that will help students strengthen their understanding of cause and effect in their science models.